My name is Tim, and I'd be interested in the watch that kept track of Planck time. In a previous video, I discussed the Planck length, the shortest distance with any meaning in science, even going so far as to calculate how many Planck lengths wide the observable universe is. But while Planck length is certainly tiny, about 1.6 times 10 to the negative 35 meters, there is a number related to it that is even smaller. Planck time is the amount of time it takes light to go one Planck length, totaling 5.391 times 10 to the negative 44 seconds. It is such a short amount of time, there are more units of Planck time in 1 second than there have been seconds since the universe began, with each passing second containing 1.855 times 10 to the 43rd units of Planck time, or 18 tridecillion 550 duodecillion. Now the definition of a second isn't a certain fraction of a day, since the amount of time it takes Earth to complete one rotation is constantly fluctuating by small amounts. Instead, 1 second is measured by counting the number of times the outermost electron of an atom of cesium-133 oscillates between two levels, something we do know is constant and is what atomic clocks use to keep track of time. The exact definition of a second according to the International Bureau of Weights and Measures is 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. So in 1 unit of Planck time, it completes just 5.955 times 10 to the negative 34 of an oscillation. Looking at it another way, it takes 2.017 times 10 to the 33rd Planck units, or 2 decillion 17 nonillion to complete one oscillation. To give you another idea of how fast this is, the world's fastest supercomputer is Summit, unveiled this past summer by the US Department of Energy and IBM. The $200 million machine has a peak performance of 200 petaflops, or 200,000 trillion calculations per second. In order to gather enough humans to equal that output, doing one calculation per second each for an entire year, you would need to gather 6,337,753,124 humans, or over 83% of the world's population. So, Summit can complete a total of 1.078 times 10 to the negative 26th of a calculation in a single Planck unit, meaning it takes 9.275 times 10 to the 25th, or 92 septillion 750 sextillion Planck units to complete a single calculation. But what I want to know is how much Planck time has passed since the universe first began. So we know how many Planck units are in a second, but how many seconds have passed since the universe was first created? Starting with commonly used time periods, we know there are 60 seconds in a minute and 3,600 seconds in an hour. That would make a day 86,400 seconds long, and a solar year, the exact time it takes the Earth to revolve around a sun, an average of 365 days, 5 hours, 48 minutes, and 45 seconds, equal to 31,556,925 seconds. Calculating up from there is easy, as now we just have to add zeros, as a decade would be over 315 million seconds, a century has 3.15 billion seconds, a millennium 31.55 billion, a million years has 31.55 trillion seconds, and a billion years 31.55 quadrillion seconds. So in the approximately 13.8 billion years the universe has existed, 4.35 times 10 to the 17, or 435 quadrillion 485 trillion 565 billion seconds have passed. So a little quick multiplication and we come up with approximately 8.078 times 10 to the 60th, or 8 novemdecillion 78 octodecillion Planck units since the Big Bang. To give you an idea of just how many that is, let's make each one of those Planck units equal to a full second. That amount of time would be, from the beginning of the universe, equal to 2.559 times 10 to the 53rd years, or 255 sextillion 990 quindecillion. Now there is no way of knowing for sure how long the universe is expected to last, but some estimates state the last of the stars will burn out 100 trillion years from now, next week compared to 255 sextillion, leaving only neutron stars, black dwarfs, and black holes. All remaining matter will either decay or be consumed by a very few, extremely large remaining black holes in about 10 to the 30 or a nonillion years. Still, that is nowhere near as many seconds from now as Planck units from now to the Big Bang. The only time frame that compares would be the evaporation of those black holes in approximately a googol years, 1 followed by 100 zeros. I want to change gears a bit and talk about an even bigger number, a number that, despite being so massive, you probably have some experience with it. 52 factorial. A factorial is the product of an integer and all integers below it, and is how you could figure out the number of different ways there are to organize any given number of items. Want to organize 4 objects in a given way? Multiply 4 by 3 by 2 by 1, and you come up with 24 ways to order them. Add in a 5th item to organize, and multiply 5 by 4 by 3 by 2 by 1, giving you 120, and so on and so forth, with the product going up exponentially every time. So 52 factorial would come out to be 8.065 times 10 to the 67, 80 unvigitillion, 650 vigintillion, or the number of ways there are to organize a standard deck of playing cards. That means if you are somehow able to reshuffle a deck of cards every time a Planck unit has passed since the creation of the universe, you could have gone this entire time without seeing the same order repeated. In fact, you would not have made much of a dent at all, as there would still be over 80 unvigintillion ways to go. Keep shuffling once every Planck unit, and you would have to keep going for another 4.348 times 10 to the 24, 4 septillion, 348 sextillion seconds, or 1.377 times 10 to the 17, 137 quadrillion, 787 trillion years, long after the last stars are expected to burn out before you would start seeing repeated patterns. When counting seconds since the universe first began, it really shows you the power of 10. Now I certainly would have expected that number to be longer than 18 digits long, but it really shows just how much it takes to make a number a single digit longer. After all, a million seconds is equal to 11 days, 13 hours, 46 minutes, and 40 seconds, but a billion seconds is 31 years, 251 days, 13 hours, 35 minutes, and 24 seconds. There are approximately 10 to the 50th or 100 quindecillion atoms on Earth, meaning if you added an atom for each one of the 8 novemdecillion Planck units that have passed, you could recreate the Earth over 8 billion times. And yet, you could hold a number much larger than all the atoms in those Earths combined in the palm of your hand. Thank you so much for watching. I really appreciate you taking the time to check out this video. If you're interested at all, feel free to subscribe and learn more about whatever it is I find fascinating that day.